So there are 10 questions on applications of tangents and normals. With this topic will be complete after these 10 questions. So a question from 2018. So given that these curves intersect at right angles, what is the value of B? So that means they are cutting orthogonally. So if they are cutting at right angles, what does it mean? At the intersection point, the angle between the tangents is 90 degrees. The tangents include 90 degrees. So first thing, if you can find the intersection point, you can try finding it. That is, you put y square equal to 6x here. But still, because there is an unknown, solving and finding exactly is not possible because they didn't give a number here. So let us assume that this point is some alpha beta. Then alpha beta lies on both. So beta square equal to 6 alpha when you substitute in the first curve. When you substitute in the second curve, 9 alpha square plus b beta square equal to 16. We have two conditions. And because they are cutting orthogonally, the derivative at this point you find out for both, you will get tangent slope and you can use m1 m2 equal to -1. So for the first curve, if you differentiate, you will get 2y dy by dx equal to 6. So dy by dx is 3 by y. And at the point P, what is the derivative? Dy by dx at the point P is nothing but 3 by beta. Similarly, you do it for second curve. The second curve is 9x square plus by square equal to 16. So if you differentiate this, you will get 18x plus 2by dy by dx is 0. So dy by dx is minus 18x by 2by, which is nothing but minus 9x by by, and you need the derivative at alpha beta. So if you find the derivative at the point of intersection, this will be 9 alpha by b beta. And since the curves are orthogonal, m1, m2 is -1. So say this is m1 and this is m2. m1, m2 is -1. So 3 by beta into minus 9 alpha by b beta equal to -1. You can cancel -7 on both sides. Then you are going to get here 27 alpha equal to b beta square. Okay, and we already had two conditions. So we'll solve all the three together. So let me list out all the conditions once. So what are the conditions? Beta square equal to 6 alpha. This condition. So I'll write them here. Beta square equal to 6 alpha. What is the second condition? 9 alpha square plus b beta square is 16. And third condition is 27 alpha equal to b beta square. Just solve all the three and find out. Solve 1, 2, and 3. And you try to find b value. So you just put this beta value here and you will be able to solve and find alpha. Put beta square as 6 alpha here. And you'll get, I think, b value after that. So from 1 and 3 only you can get the answer directly. We may not use 2. So you have to just solve these two to get your b value. That is, put beta square as 6 alpha here. You can cancel out alpha and get b value from that. And that will be 9 by 2. So let's move on to the next question. So all of you try the second one. If theta is the acute angle between the curves y equal to 10 minus x square and y equal to 2 plus x square, acute angle between the curves is theta. At their intersection point, what is mod of tan theta? So these are two parabolas which are intersecting. So you don't need to know the exact diagram. But let us suppose where they are intersecting, I want to find out how to solve them. So how to solve? Just equate y values. 10 minus x square equal to 2 plus x square. This will give you 2x square equal to 8, x square equal to 4, x is plus or minus 2. So the intersection point, if I have to write, one x coordinate will be 2, the other x coordinate will be -2. And how to find y? If you put x equal to 2 in one of the equations, so you will get y equal to 2 plus x square, which is 4. So that is 6. So they will intersect at 2 points, 2, 6 and -2, 6. And at this point, if you want to find out angle between them, so if you want to find the angle between the curves, so find dy by dx for this curve, you'll get -2x. And the other curve is y equal to 2 plus x square. Find dy by dx for this. This is 2x. And suppose I want to find the angle of intersection at point P, 2, 6. Then I can write this x as 2, then -4. And here if I want at 2, 6, then this is for x equal to this is 4. Then you can say tan theta equal to modulus of m1 minus m2 by 1 plus m1 m2. So if you subtract minus 4 by 1 plus minus 4 into 4. So this is going to be 8 by 1 minus 16 is 15. Mod is there, so we can remove the negative sign anyway. So 8 by 15 is the value. So this is there in the option, but still if you want, you can check for Q also. The angle might be same. But you can find at both the points. So if it is dy by dx at Q, Q is minus 2 comma 6. So at minus 2 comma 6, this will become 4. And for second one, dy by dx at Q, for second curve, if you write, it is minus 4. This is for curve 1. This is for curve 2. So again, you got 4 and minus 4. Earlier, you got minus 4 and 4. Now you got 4 and minus 4. When you apply the formula, you're going to get same answer. So tan theta equal to modulus of m1 minus m2 means you'll get 4 minus of minus 4. By 1 plus m1 m2 is 4 into minus 4. You will still get the same answer here, 8 by 15. So either case, the answer is 8 by 50. So now let us do the next problem. So the question says a helicopter is flying along the curve y minus x power 3 by 2 is 7. A soldier positioned at 1 by 2 7 wants to shoot down the helicopter when it is nearest to him. Then the nearest distance is. So you want to find the shortest distance from point to the line. So let's solve this question number 6 from tangents and normals. So there is a curve y equal to x cube. So usually you know the graph of the function, so you can draw. Otherwise, you can even draw a random graph. The tangent at P meets the curve again at Q. So let's say, for example, we draw a tangent at P with T comma T cube. And this tangent is meeting the curve again at Q. Then the coordinate of the point which divides PQ in the ratio 1:2 internally. So if some point is dividing PQ in the ratio 1:2, so I'll write in this order. 1:2 internally, what is ordinate of this? So Q is unknown. So first we'll have to find that Q. So you can also assume there are some T1 comma T1 cube because this also lies on the same curve y equal to x cube. So it can be something of this form. Then how to get a relation between T1 and T2 first? The derivative at P is the tangent slope. You can also equate slope of PQ. So for the curve y equal to x cube, you know the derivative is dy by dx is 3x square. And you need the derivative at the point P. So at the point P, you'll put x as t. So this will become 3t square. And this should be equal to slope of PQ, m of PQ, slope of PQ. How do you write the slope of PQ? Difference in y coordinates. That is t cube minus t1 cube by difference in x coordinates, which is actually t minus t1. So 3t square equal to, you can factorize the numerator with a cube minus b cube. So a minus b into a square plus ab plus b square, t1 plus t square by t minus t1 will anyway cancel. So from here you will be getting 3t square and t square, you subtract 2t square equal to t1 square plus tt1. This condition we are getting, we'll use this later. Then what are we supposed to find out? The point R, which is dividing PQ in the ratio 1:2. So if R is dividing PQ in the ratio 1:2, so what is P? T comma T cube. And what is Q? T1 comma T1 cube. So by section formula, what is the y coordinate? My2, so 1 into T1 cube plus ny1, 2 into T cube by m plus n, which is 3. But this answer you want in terms of T. This result you want in terms of T. So T1 has to be eliminated. And you can eliminate that using this result. So here, what is the relation you are getting? T1 square plus T1 minus 2T square equal to 0. You try to factorize this. You can split the middle term as minus T1 plus 2T1 minus 2T square equal to 0. So factorize this. So T1 into, what does it give you? T1 into T1 minus T plus 2T into T1 minus T equal to 0. So T1 minus T into T1 plus 2T is 0. So either T1 will be equal to T or T1 will be equal to minus 2T. So since T1 and T2 are not equal, this is ruled out because they're different points. So T1 is minus 2T. T1 is minus 2T. And therefore, what is Y? Y was T1 cube plus 2T cube by 3. Put T1 as minus 2T, it is minus 2T whole cube plus 2T cube by 3. So which is nothing but minus 8T cube plus 2T cube minus 6T cube by 3. So that will give you minus 2T cube as the answer. So let's check with the options. So we have first option as the answer. So then we'll do question number 7. If these curves intersect at an angle of 90, what is the condition? So already I gave a standard formula. If you remember, if there is some curve a1 x square plus b1 y square equal to 1 and a2 x square plus b2 y square equal to 1, I derived a condition for orthogonality. 1 by a1 minus 1 by b1 is equal to 1 by a2 minus 1 by b2. This is the condition for orthogonality. For two conics, we derived this and I asked you to remember. So if you just compare with that, here a1 is 1 by a. So instead of a1, you have 1 by a. So 1 by a1 would be just a. And b1 is 1 by b. So 1 by b1 will be b. Similarly, instead of 1 by a2, you have c. Like you have a2 is 1 by c. So 1 by a2 is c. And b2 is same as 1 by d. So 1 by b2 is d. So directly we can write the answer as second option using that condition which we remembered. So just compare with this and use that formula. So then we have this question. If the tangent at P on the curve passes through the origin and then x1, y1 does not lie on the curve. So some random curve is given. So let us draw it randomly. The tangent at P x1, y1 is passing through origin. Then x1, y1 does not lie on which curve? So basically you find out the locus of x1, y1 and you can verify, I think. So what is the first condition? It lies on this curve. So it lies on the curve. P x1, y1 lies on the curve y equal to x cube plus 3x square plus 5. So one condition that you can write is it satisfies the curve. So y1 equal to x1 cube plus 3x1 square plus 5. Condition 1. The second condition is when you find the derivative at P, you will get tangent slope and that passes through origin. So slope of OP, if you find that should be equal to derivative at P. So dy by dx at P, x1, y1 should be equal to slope of OP. Slope of OP. So what is the derivative? Dy by dx, when you find out, it is actually 3x square plus 6x. If you differentiate this, you'll get 3x square plus 6x. At x1, y1, it will be 3x square plus 6x1 equal to slope of OP. So what is origin? O here origin. And what is P x1, y1? Slope of OP would be y1 minus 0 by x1 minus 0. So from here, you can see that y1 is equal to, if you cross multiply, you'll get 3x1 cube plus 6x1 square. This is condition 2. So you can solve 1 and 2 to find x1 and y1. So you say solve 1 and 2. And how to solve it? Directly equate the value of y1. So x1 cube plus 3x1 square plus 5 should be equal to 3x1 cube plus 6x1 square. So just equate the y1 values and try to solve the equation. This equation becomes x1 cube terms you can group. 2x1 cube plus 3x1 square minus 5 equal to 0. So to solve this clearly, you can see x1 equal to 1 will satisfy. So by trial, you can guess one root. So x1 equal to 1 is one root by trial. Rest of the roots, you can actually use synthetic division. So right here, coefficient of x1 cube, then x1 square. x1 is not there, so 0 and constant. Usually the first root you try should be a factor of this. And we already know one root, so I'll write 1. Carry this 2 down, then 2 into 1, write it here. 3 plus 2, 5. 5 into 1, 5. 0 plus 5 is 5. 5 into 1, again 5. Minus 5 plus 5 is 0. So basically, we have found one root by trial. The rest of the factors, so like if x1 minus 1 is one factor, the rest of the factors will be having the coefficients as 2, 5, and 5. So it should be 2x1 square plus 5x1 plus 5. So one of the roots you can take x1 equal to 1. The other equation, if you try to solve, so what is the discriminant? Is it negative? D is 25 minus 40. I think it is negative. So no real roots. So this you can skip. So you can take only x1 because these roots are imaginary. Take x1 as 1. And then what is y1? So from the previous slide, you can see y1 is 3x1 cube plus 6x1 square. So you can just put x as 1. This is 3 into 1 cube plus 6 into 1 square. And therefore, what is this? 9. So y1 is 1. So the point x1, y1 is 1, 9. So once you get the point as 1, comma 9. So what is x1, y1? 1, comma 9. So which curve it is going to satisfy? If you substitute in the first one, you will get 1 square plus 81 by 81 equal to 2. So this will satisfy. If you substitute in the second one, but anyway, they said it does not lie on which curve. So we cannot mark this answer. It lies on this, of course, but if we want to write the curve on which it will not lie. If we substitute 9 here, 9 square by 9 minus 1 square equal to 8, it will satisfy this also. Then here y1 is, y is 9, 4x square plus 5. This is also satisfying. The only thing which doesn't satisfy would be this one, because x by 3 would be 1 by 3, y square is 9, not equal to 2. So except this, x1, y1 satisfies all the three other curves. So fourth option is the answer, because they said it does not lie on which curve. So option 4 is the answer. Question number 9. If these curves cut orthogonally or are at right angles, what is 4k power 6? So orthogonal means at the point where they cut, the product of the slopes should be -1. The tangent slope, if you find out, the product should be -1. So if m1 is the slope of one tangent, m2 is the slope of other tangent, m1, m2 is -1. And the point where they intersect, you can actually find out by solving. So like, for example, if you put x equal to y power 4 here, xy equal to k, you put x as y power 4, y power 4 into y equal to k. So y power 5 will be k, y is k power 1 by 5. And then what is x value? Y power 4. So it will be k power 4 by 5. So the intersection point, you can assume k power 4 by 5 is x coordinate, k power 1 by 5 is y coordinate. At this point, when you find the derivative for both, that m1, m2 should be -1. So if you consider x equal to y power 4, we'll differentiate and write dx by dy first. That is 4y cube. So dy by dx will be 1 by 4y cube. This is for the first curve. For the second curve, xy equal to k, you can write x dy by dx plus y equal to 0 by applying product rule here. And dy by dx is minus y by x. So at the point P, when I write the tangent slope for this first curve, dy by dx at the point P, this is 1 by 4 into y cube. And what is the y coordinate of P? K power 1 by 5. So k power 1 by 5 whole cube. So it is k power 3 by 5. And for second one, if I write derivative at P, minus y by x. So y coordinate is k power 1 by 5. X coordinate is k power 4 by 5. So k power 1 by 5 by k power 4 by 5. So if you divide, it is minus 1 by k power 3 by 5. And the product of these slopes should be -1. So you can write m1, m2 is -1. So 1 by 4 into k power 3 by 5 in the first one is the m1 slope. Second one, -1 by k power 3 by 5. This is equal to -1. Both sides you can cancel minus, and this will be 4 into k power 6 by 5 equal to 1. And you want to actually find here 4k power 6. Okay. So suppose you raise it to the power 5, what will you get? 4k power 6 by 5 whole power 5 will be equal to 1 power 5. And this will become 4 power 5, that is 1024 into k power 6 is equal to 1. And you want to find 4k power 6. So what is 4k power 6 then? So what is the value of 4 power 6 actually? It is 2 power 12. So 2 power 10 into 2 square. 2 power 10 is 1024. 4 into 1024. So if I multiply with 4 on both sides, then this will become 2 power 12 k power 6 equal to 4. So or you can just now write this as 4k power 6 is equal to 4. So the answer would be 4 for this. Area enclosed by x-axis, the tangent and normal drawn to this curve at the point -23 is A. What is 8A? So the curve looks a little bit complicated, but see if it can reduce into a simple equation once. Yeah, anyway, they asked you the area formed by x-axis, tangent, and normal. Then I don't think it's difficult. Differentiation, you can use parametric differentiation for this. So dy by dx equal to what is the parametric derivative formula? Minus dou f by dou x by dou f by dou y. So using this, you can write minus of partial derivative with respect to x means you will treat y as constant. So 4x cube derivative will be 12x square. For 3xy square, we'll treat 3y square as constant and derivative of x will be 1. For 6x square, derivative is 12x. For 5xy, we'll treat 5y as constant and derivative of x will be 1. 8y square is constant, derivative is 0. 9x derivative is 9, 14 it is 0. This is dou f by dou x. And when you do dou f by dou y, we'll treat y as variable, x as constant. So for 4x cube, derivative is 0. And in 3xy square, 3x is constant. Derivative of y square is 2y. 6x square, derivative will be taken as 0. For minus 5xy, you treat minus 5x as constant. Differentiating y will give 1. Minus 8y square, derivative is 16y. 9x and 14, derivative is 0. So in the denominator, I treated as x as constant. Numerator, I treated y as constant. So, and you want to find the derivative at minus 2, 3, you can substitute minus 2, 3 for x and y there. So if I want the derivative at minus 2, 3, put x equal to minus 2 and y equal to 3. So 12 into minus 2 square is 4. So 12 into 4, 48. Minus 3 into y square. Y square is 9 into 3, 27. Then again 12 into minus 2, minus 24. Minus 5 into 3, minus 15, plus 9. By put the same values in denominator, we have minus 3x into 2y here. So minus 6 into xy would be minus 2 into 3. Minus 5x is minus 5 into minus 2. Minus 16 into y, that is 3. So just calculate this and find the slope. So what is the slope that you are going to get from here? I'll give it directly. It is minus 9 by 2. And once you got this, we have the point minus 2, 3. So what is the point we have? Minus 2, 3 is the point that we have. And the tangent slope that we are going to get is minus 9 by 2. So using this, what is the tangent at P? If you write down tangent at P, you can use point slope form. Y minus 3 equal to slope into x minus of minus 2. And the normal at P, if you are writing, the equation is y minus 3 equal to same point, but slope of normal will be taken as 2 by 9 because the tangent and normal are perpendicular into x plus 2. So just simplify this and write down the equations. So the tangent equation will be, what is the tangent equation when you simplify? I'll write that directly. 9x plus 12y plus 12 equal to 0 you'll be getting. This is for tangent. For normal, you'll be getting 9y minus 2x equal to 31. So once you know this, you just have to find out area formed by these two with x-axis. So just draw that. So the tangent, what are the intercepts? You can just draw this. This is the tangent and this is the normal. So draw both. For the tangent, x and y intercept both are negative. So it may be some line like this. You will know x and y intercept by putting y0. X is minus 12 by 9. And what is minus 12 by 9? Minus 4 by 3, comma 0. And similarly, where it cuts y-axis, further you put x0, you will get minus 6. So this is the point where tangent cuts the coordinate axis. Let us draw the normal also. When you put x0, you get y as 31 by 9. So it will cut somewhere here. And when you put y0, you will get x as minus 31 by 2. It will cut somewhere here, minus 31 by 2, comma 0. So once you got this, this is the tangent and this is the normal. We want to find out area of triangle formed by these two with the x-axis, this area. So how do you find that? You can take the base by taking the distance between these 2 points. Let us suppose this is some A and B. So area of this triangle means you can take the base AB first. What is the base AB? Mod of difference in x coordinates. So you can find that. And height, if you want, you can just solve the equations. You will get a y coordinate. Distance from x-axis will be the y coordinate. This height you can find out. Then you can write the area as half base into height. So can you write that directly? So I'll give the answer. You can solve and check. Area will be 85 by 4.